Okay, it's time for Module 5. Here in 3D for Fit, we'll talk about fitting a simulation, tools for fit, and fitting on an avatar. When we're fitting a simulation, your team responsible for fit needs to have a solid understanding of the differences inherent in garments versus virtual simulations. 3D simulations and physical samples are different representations of the same thing. So when I talk about the digital component versus the physical component, I like to compare that to MP3 versus CDs. But when we're looking at how we interpret our garments in a virtual environment, it's more of film versus novel, where it's same story being told, but told in a different way. So you want to understand from a fit perspective what the differences are and how the garments are put together in 3D versus physically, so that you can start to spot the differences, because those differences become the key to getting the job done well and faster. Remember, simulations are not cut or sewn in sequence the same way that we have to do with physical garments. So these can have an impact on the outcome of the garment as well as the outcome of the simulation when we don't have all of those components there. In 3D, many of the elements and details for finishing are just optical effects. So when we're working with physical garments, we have to understand these differences. So for example, in one of the earlier modules, I mentioned the impact understitching may have on a garment, and it's not necessarily going to have the same effect in 3D, which is totally okay. But we also have other things, like if we think about our jeans and a flat felt seam. When you're looking at a flat felt seam, usually as it goes through the machine, it takes about 5/8 seam allowance from one side and 3/8 from the other. And this gives us a slight skew depending on how we measure our pants. And sometimes it even results in one pant leg being a 1/4 inch shorter than the other. These are elements that you're not going to see in 3D the same way because, again, the garments aren't sewn as they are in the real world. These are little details that maybe the designers would not be as in tune to, but your fit team definitely needs to know and understand these things to make sure the garments are being interpreted correctly. Another example of differences you may see in your physical garment versus your virtual simulation are problems that are caused by sewing. We all wish our garments were sewn correctly, but the fact is they are not always. There are also other areas that problems can pop up that don't relate back to the actual pattern geometry. So for example, if you look at your physical garment and you're seeing a problem that you didn't see in your virtual sample, that's a sign that that issue is probably not caused by a pattern issue. It's more likely because of a sewing error or even a cutting error or something that happened in the finishing of the garment. So if we take a deeper look at what I mean by that, here's an example. Sometimes when we take our curved necklines on knitwear, when we run those through the sewing machine, sewing operators have a nasty habit of wanting to straighten that out to run it through the machine in a straight motion. What that can do is actually stretch and widen the neckline. And then when we see that neckline on the form, it can stand away from the body. So the first thing that your fit team or your tech team is going to want to look at is comparing the physical pattern to that garment to make sure that the pattern was obeyed. If the pattern was obeyed and you're just seeing some stretching, look at your 3D sample. If you're not seeing that same stretching or it's standing away from the body in your 3D sample, that's a sign that your sewing has distorted the shape of the garment. This happens quite a lot, and I've seen it in other examples, but this is just one of those really clear ones. If you don't catch this mistake here, one of the things that can happen is your tech team may say, oh, this neckline needs to be corrected. And then they'll send instruction to the pattern maker or the factory to correct the pattern for what is a sewing error. Then we end up in this never-ending loop because the same problem can happen over and over again. Just because we adjust the pattern for the bad sewing doesn't mean the sewing gets any better. So 3D can be a very powerful tool, especially if you know what to look for. And again, you know how to spot those crucial differences between things that can happen in a physical sample and things that can happen in the virtual samples. So when we think about the example of spotting sewing issues, This outlines 3D as being such a strong component of troubleshooting. If your organization is one that has issues with your factories and sewing, and you're seeing the same problems over and over again, and you end up with this never-ending loop of samples, which is not at all sustainable, and it becomes one of the problems that our industry is really, really struggling with, 3D can be the tool to help you get away from that. Now, 3D will not tell you what the problems are always. You still have to have the right team and the right skills to spot the issues in 3D as well as in the physical samples. So if you're having issues with physical samples already and your tech team or your fit techs don't understand how to reduce these problems or how to get to the bottom of what's going on at the factory that's causing issues in the samples, you're definitely going to want to get some training there and have people for your team to talk to. It's always great to bring in people who really understand the space, understand working with patterns in factories. If you have 3D to help you with that, then you get through these issues so much faster. And then those issues can become a thing of the past. 3D also provides a world of opportunities in terms of the new tools that we just don't have in the physical world. So when we talk about the fit process in the physical world, what tools do we have? We usually take our garments and we can put them on a fit model or the dress form, but we can't dissect garments the same way that we can in 3D, and we don't have other fun tools that are only possible in the digital space. Some of those tools are things like toggling the transparency of the garment, where you can see right through it, which isn't always appropriate in the physical world. We also have the ability to hide and show certain components. So if you have a technical design team that's working on 3D simulations that will go to the factory, you can also dissect some of those 3D simulations, hide certain pieces to allow the factory or whoever is going to construct this garment to see inside of it and call out certain details and construction elements. So it's always great to use there. When you're dealing with 3D, you also have the opportunity to do instant pattern modifications and see the impact of those pattern modifications immediately. These are usually things that we have to wait a while for. I've even seen some pattern makers who will plot out half-scale versions of their paper patterns and tape them together to get a better idea of what the final garment will look like, but it's in paper, which is not really going to give you the same great visualization that you could get with 3D. So if you want to make sure you're getting those patterns correct the first time, it's always great to have a 3D component right there that you can make the adjustment, see the impact, and work back and forth that way. Again, great way to reduce samples. You also have a lot of creative ways that you can display your garments, and these are things that may only be used in the fit process, but they're also cool things to show your customers. Here's an example of a mask that I made for myself to wear, and I wanted to highlight the different components in the mask so I could take the 3D simulation of it and separate the pieces so that we can really see all the details and how all of the components fit together. This is also great for me to be able to share with other people who may want to make the same mask. It turned out to be a very successful design, and I was able to wear it over and over again, wash it. It has a filter that can pop right into it without having to fold or adjust it. So it's been great, and this gives me a great way to communicate it. One of the most loved tools in 3D is pressure and tension mapping. This gives you the ability to visualize tension in the material or pressure applied to the form. And it's a great way to get through some of those early fit issues you might have, and just to understand how that garment is interacting with the body. It's a great tool. When you're working with tension mapping or pressure mapping, it's important to have a gauge to be able to understand what those maps mean for your garments and your materials. Just because you see an area on the garment that might be red, it doesn't mean it's a bad thing. People see that, oh, well, we need to fix it. We need to neutralize it. It's not always the case. If we think about skinny jeans, there are certainly areas where you're going to want those to fit a little more snug and tighter to the body, so it's okay. One of the best ways to get an understanding of how these garments and these maps are interacting with your bodies and what that means to your end consumers is to get some feedback. So early on in the sampling process, definitely save out some images of your 3D garments and what those tension maps look like. Then as you get closer to finalizing that design to go into production, have someone try it on your fit model or whoever is doing the fit for your garments, and get an understanding of how they say the garment feels compared to what you're seeing in the mapping. This sort of feedback loop really allows you to build an understanding, again, of what those maps mean for your garments. Also remember, as we talked about in the bodies module, that your avatars are solid. So your pressure and tension maps may respond a bit differently than we're expecting, again, because those bodies are hard. So it's not pressing into soft tissue, it's pressing onto a statue. So make sure you keep that in mind as you're working with pressure and tension maps. All right, let's talk a little bit about fitting on an avatar. As we just covered, we have to remember that our avatars are hard-bodied, but they have a lot of great tools and great capabilities that we're going to want to take advantage of. One of the great things that we can do with our avatars is have them move in the garment. In some cases, some solutions also allow you to move the avatar in the garment while the pressure and tension map is on. This creates a very, very great visual. It's something our members in the C-suite always love to see and think is very, very cool and of the best technology. So definitely make sure you're taking advantage of functions like that if they're available to you. But from a fit perspective, always think about how that avatar's body is changing as it moves. For example, if I'm creating a custom pair of pants or, fitting a pair of pants that will go in production, I may have my fit model sit down in those pants. One of the most important things about having the fit model do that is to understand how the garment is reacting as the body mass redistributes as they're sitting down, and is it still comfortable and things like that. If your avatar's body mass isn't redistributing exactly the way it would in the physical world, which is a difficult thing because they don't have soft tissue, just make sure you're aware of that. And again, this is another good point of comparison to look at your physical sample as compared to the mapping that you're seeing in your virtual sample. Other than just motion, there are a lot of other really great tools that you will find with your avatars. So if you're working with virtual forms that match your physical forms, they will often have lines and markings that tell you exactly where the hip level is, exactly where the bust level is. And it's great to have these things to compare in your garment because then you can verify the balance of the garment. Remember, your hip line on any garment or say a skirt needs to be exactly in line with the hip line of your form or the body that you're making it for before you start to make fit adjustments. If you start making fit adjustments and pulling in here, letting out there on a garment that isn't balanced correctly, you can end up with a whole world of other issues. So when you use tools like being able to toggle the transparency and make sure the lines on your patterns and your balance lines are matching your avatars, that's another helpful tool for fit. It's easy to overlook, but if you know what you're doing, you'll understand it and understand the importance of it. And that's something you can't do in the physical world. I wish our fit models had the ability to just show and hide the balance lines on their body so I can make sure my garments are fit correctly, but they create a little bit of extra work. But it's okay. That's why we have 3D. 3D is also great for just giving you examples of how those garments are going to move in the real world. One of my good friends that I met on LinkedIn, we haven't had the pleasure of connecting personally yet, but we both love 3D, has always posted great examples of garments that she's designing and creating the patterns for herself in 3D and showing us how they move around in the real world. So here's an example of that. All right, that wraps up some of my considerations for fit. This is an area that I love as well. I don't love fit as much as fabric, but you can see how they work hand in hand. But I'm always very interested and engaged to see how people are using 3D in new ways to enhance the fit of their garment. So let's keep this conversation going. But for now, we're going to move to Module 6, which is all about understanding your organization.